Welcome to a new video. We are going to do a regression project in this video. I'm going to work with a car prices dataset which I took from Kaggle, and I will add the link of the dataset in the description of this video. We are going to do data analysis, feature engineering and machine learning applications in this video. Let's directly start. We are going to start by importing the libraries. Let's import pandas firstly. We are going to import matplotlib. .pyplot as plt, import seaborn as SNS. We are going to do different imports at the feature engineering and machine learning part, but this is enough for now. Now we are going to transform our data into a pandas data frame using read CSV from pandas. Read CSV and our dataset name car prices Poland.csv. Let's check if our data is read successfully. Here we displayed the first 5 rows and we can see that our data is read successfully. We have both numeric and categorical columns that we have an index column, mark, model, generation name, year, mileage, volume engine, fuel, city, province and price. So if you want to display more than 5 rows, you can just change this number, like you can make it 10 and you are going to get 10 entries in here, or you can use tail method for seeing the last entries in the data frame. Let's check data frame.shape for getting the row and column count. We have 11 columns and more than 110,000 rows in our dataset. We can use data frame.information right now. For getting general knowledge about our dataset, we have information about memory usage, data types in the columns, and non-null values. Great, but I think I'm not going to use all of that columns on my unlisted part, so we can just call data frame.columns here and we can drop the unnecessary ones. So I want to drop the unnamed thing here and the generation name. Because I'm not going to use them, I will just say data frame.drop columns and I will give the names of the columns that I will drop: unnamed, 0 and generation name. And I'm just going to run like this for showing you something that here we don't have that columns, but if I call the original data frame here, you're going to see that we still have them. So what we can do is we can just assign our data frame like this, or we can simply use inplace here. By using inplace here like this, you're going to see that our original data frame is going to be updated and we don't have that columns inside in here right now. Don't forget to use inplace if you want to set your change in the original data frame. Great, let's check for NA values. For that we will say data frame.isNA, but if you run like this we are going to get booleans in our data frame cells, so we will just use sum here for getting the sum of the NA values. And as we can see, we don't have any NA values in our dataset. Okay, let's check for duplicates. So we will say data frame.duplicated right now, and you are going to see we will get booleans like this, and if we use sum like this, we are going to get the count of the duplicated rows. So let's remove these duplicates. We will say data frame.drop duplicates, and we are going to run this, and if we do that, our original data frame is not going to be updated because we didn't use inplace here. And if we use inplace, we are going to see that we will not have any duplicates in our original data frame. Great, let's start our analysis. Let's count unique values in the mark column. For that we will say data frame mark and we will use value counts for that. We can see that the leading brand is Audi in here. So we can also manipulate this output, like we can just say head and 5, and we will get, actually if we remove this 5, it's going to display 5. It's going to take the 5 leading car brands. So if we say tail, it's going to get the bottom 5, and you can use that on the visualization, because if you do a pie chart, for example, with all of these brands, it's not going to look good. But if you just take 4 of them and do a pie chart with these values, you are going to see it's going to look a lot better. Great, let's just clean it and let's count the unique values in the fuel column. So we will say data frame fuel and we will use value counts again. And we can see that the leading fuel type is gasoline, and we have diesel, LPG, hybrid, electric, and CNG. Okay, let's do some group bys. Let's group by mark and calculate the mean price for each car mark. So we will say data frame.group by, and we are going to group by mark, and we are going to take the price values and we will use mean aggregation function in here. Also, I will remove that was a typo, and we are going to get the mean price per mark. So we can just sort this, like we can use sort values, and we can just set ascending as false for getting them in descending order. So we can see that the most expensive car we have in our data is Mercedes. Also, if you want to see the cheapest at the first place, you can just say ascending order, and you are going to see that the cheapest is the Citroen. Great, let's do a sorting operation now. Let's sort the data frame by price in descending order. So here's our data frame, and we will say data frame sort values, and we will say by price, and we are going to set ascending as false since we want to sort them in descending order. Great, let's create a correlation matrix and then a heat map. So if we want to create a heat map and calculate the correlations, we need to take the numeric columns. So for taking the numeric columns, I'm just going to say that numeric columns, and I will use data frame.select data types, and I will say include, and I will give the type of integer and float. And now I'm going to say correlation matrix, and I will say numeric columns dot correlation. Okay, we can start our visualizations right now with the heat map. So we will just say seaborn.heatmap, and we will give the correlation matrix in here, and let's say up true, and we will say color map cool warm. I love using cool warm when I'm doing heat maps. Also, we can say line width, and we can just say 0.5 in here for it to be look better. So at the next step, we will give this a title like correlation heat map, and we are going to use plt.show. Here it is. Great, let's plot a histogram of the year column. So we will say data frame year, and we will use plot, and we will use histogram in here, and let's just set bins and 20, and we can change this later on. I think 20 is going to be good. We will say plt.title distribution of car years, and we will say plt.show again, and here we can say we got our histogram. We can just change this histogram, like we can just do bins equals to 5, and you're going to observe the change in the plot. I think 20 was the best one. Let's go with the 20. Great. Let's create a scatter plot of my wage and price. So we will say plt.scatter, and I'm going to say data frame my wage and data frame price. Also, I'm going to set the alpha as 0.5. Then I will say plt.xlabel, and it's going to be the my wage, and plt.ylabel, and it's going to be the price. Then I'm going to give this plot a title as scatter plot of my wage and price, and I will use plt.show at the end. So it's scientific notation, like we can see is in here, and we can say that when the my wage decreases, the price increases from this. Okay, let's generate a bar plot of average price by car mark. So we will say mean price by mark, and we will use data frame.group by. We are going to remember this, we did this before, mark, and we will take the price, and we will use mean in here, and then we will say mean price by mark, and we will use plot. Then we will say kind, and it's going to be a bar plot, and then we are going to say plt.xlabel, it's going to be car mark, and plt.ylabel, it's going to be average price, and we are going to say plt.title, it's going to be average price by car mark. And let's use plt.show again, and here it is. Also, it's a nice time for me to show you the sorting and using the head and tail methods for creating better graphs. So I'm just going to take this in here, not in here, in here, and you're going to see the result of this. But if we say sort values, and we are going to sort by ascending false, and we are going to get the highest prices, you can see that we get the highest at this part. But in the graph we don't have. So if we just copy this and set this, you are going to see that we are going to get the graph by descending order. So if we use sort values ascending false with the group by here, you're going to get a graph like this. Also, if you say true instead of false, it means that you are getting the graph in the ascending order. You can see that it's going to be from decreasing to increasing. Also, what we can do is let's rechange it to the false, and if let's say we just want to take this first 5 cars in our graph, so we can just use .head and we can run like this, and it will get the first 5. So what's the trick on it is, if we say head in here, we are going to remember that if we say head, we are just going to take the 5 of them. So if you say tail instead of head, you are going to get the bottom 5. Here it is. Remember, it was string. Great. Okay, let's create a box plot of car prices to visualize the distribution and identify outliers. So we will say seaborn.boxplot, and we will say x price, and we are going to set the data as data frame, our data. And we will say plt.title box plot of car prices, and we will use plt.show. Here it is. So we have outliers in here, but I'm not going to remove them in this project. I can do in the further ones. I don't think it's going to affect a lot, but you can do that if you want. I have a full video on outlier handling, and you can just take the codes from there. I think this much of outliers is not a problem, and we are good. Great. Let's create a bar plot of the top 10 most common car models. So by the top 10, I'm saying that we are going to take the head. Okay, we can just go like top 10 models, and it's going to be data frame.model, not dot, data frames model column. We will say value counts, and we will just say head 10. Okay, so what we are going to do now is we will say top 10 models.plot, and we are going to set the kind as bar, and then we will say x label is going to be car model, y label is going to be frequency, title is going to be top 10 most common car models, and we will just use plt.show at the end, and here it is. Okay, let's create a scatter plot of engine size and price. So we will say plt.scatter, and we will take data frame volume engine, and then we will say data frame price, and we will set the alpha as 0.5, and let's say x label is going to be engine size, and y label is going to be price, and then we are going to do plt.title scatter plot of engine size and price, and let's use plt.show. Here it is. Great, let's plot a histogram of car mileage, and we are going to focus on low mileage cars. So what I mean by low is we are going to take the ones with less than 50,000. So for that we will say data frame, and we are going to filter our data frame like mileage, and we are going to take the less than 50,000 ones, also it's mileage, And we are going to see from this, actually there is an error, mile age. Now it's correct, and we can see that we have the cars with less mileage than 50,000 in here. So from here I will say mileage for taking that column. I'm just showing you step by step, and then we will say plot, and we will use histogram, and let's set bins as 20, and let's give it a title like plt.title distribution of low mileage cars. And I'm just going to share you the plt.show in here, and we can see that our histogram is in here. Great. Let's create a bar plot of the count of cars in each city. So we will say city counts, and we will say data frame city, and we will use value counts, we will use sort values, and we are going to set ascending as false, and let's use head 10 in here. Now we will say city counts dot plot, and we are going to set kind as bar, and let's give it a x label like city and y label like number of cars, and let's give it a title like car count by city, and use plt.show at the end. Great, let's do some group bys. Let's group by car fuel type and calculate the average price for each fuel type. Actually, group bys are a great part of any analysis because it will lead you to have a lot of insights about your data set, and I really use that when I'm doing data science projects or I'm working in any data related thing. So we will say fuel average price, and we will use data frame that group by fuel, and we are going to take the values of price and we will use mean, and let's say fuel average price. Great. Also we can sort this like you already know, sort values ascending false, and here we have in descending order. Great. Also it makes sense that electric cars are the most expensive ones. Great. Let's group by the car year and calculate the median mileage for each year. We will say median mileage by year, and we are going to say data frame dot group by year, and we are going to take the values of mileage dot median, and let's get our values. There's a typo at the median, so if we do like this it's going to work. Great. So again we can just do sort values, and we can just say ascending false, then we can just take the first 5. I think it's going to be enough. Great. Okay, I'm going to show you now grouping our data by 2 columns instead of 1. Let's group our data by car mark and fuel type and calculate the maximum engine size for each combination. So we will say maximum engine size by mark fuel, and we will use data frame.group by, and this time we are going to give multiple columns mark and fuel, and we will say vol engine dot maximum engine size by mark fuel, and here it is. Great. Let's group our data by car province and calculate the total count of cars in each province. So we will say car count by province. I'm not sure if we do a visualization on this. I remember like we did. If we did, I'm sorry. We will say province, and let's say mark, and we're going to use count, and let's get car count by province. Great. Let's group our data by car mark and model and calculate the average price for each combination. So we will say average price by mark and model, and we will use group by with multiple columns again. We will say mark and model, and what we are going to do now is we will take the price and we will use dot mean again, and we will say average price by mark model. Great. Let's group our data by car year and calculate the total count of cars manufactured in each year. So we will say car count by year. We will use data frame dot group by year, and we will use mark, and then we will use count. And let's get the car count by year. Also, for removing the complexity, let's say sort values, and we will say ascending equals to false. And here it is. It makes sense that with the increasing technology over the years, it's easy to create cars. Great, let's do one or two more group bys and do one or two more visualizations, and then we can get into feature engineering and machine learning. Let's group our data by car mark and province and calculate the average mileage for each combination. So we will say average mileage by mark and province, and we will say data frame dot group by, we will say mark and province. Then we will say mileage, and we will use mean. And let's get this. Okay, let's do a final group by, and then let's get into the visualizations. So for the end, let's just say we are going to group our data by car province and fuel type and calculate the minimum price for each combination. So let's just go like minimum price by province fuel, and we'll use data frame dot group by, we'll say province and fuel, and we'll say price, and we'll use mean. And let's get the minimum price. Actually, I made a typo like that. Minimum price by province fuel. Here it is. Okay, let's create two plots and then get into feature engineering. Let's group our data by car mark and plot the average price for each car mark. We did this group by, this time we are going to plot it. So we will say data frame group by mark, and we will take the price and mean of this. Then we will say sort values, and it's going to be in ascending, false, means descending order. Then we will use plot, and kind is going to be equal to a bar. Then we will do plt.xlabel, and it's going to be car mark, and we will do plt.ylabel, it's going to be average price, and we will do plt.title, it's going to be average price by car mark, and we will use plt.show at the end. And here it is. So again, we can just add .head and 10, actually let's say like 6 in here, and we are going to get the top 6. Okay, let's create the final graph. So we will say, let me think, let's group our data by car fuel type and plot the maximum engine size for each fuel type. I think it's going to be a unique one. We didn't do that in the video. So we will say data frame.group by fuel, and we will say volume engine, and we'll use maximum, and we are going to say plot kind is going to be equal to the pi, and I think it's it. Let's say plt.title, and we will say maximum engine size by fuel type, and we will use plt.show. Great. Also, you can add a parameter like auto pct, and we can just say percentage sign 1.1 f percentage, and you are going to see the change in here. We have the percentages right now. Great. Let's do feature engineering before machine learning. It was all for the data analysis part. So let's just call our data again and take a look at that. So the price is going to be our target in the machine learning models, and others are going to be our x values, but I'm not going to take all of them because I think taking the model is pointless. So we can just say for the x, we will say x is going to be equal to data.ilog, and we will say give me the all columns except the last one. So actually it's data frame, not data, and you are going to see that X has all the columns except price. So for the Y side, you will say data frame.ilog, and we will do -1 for getting the last one. So if we check Y in here, we can see we only have the last column in here. So let's do some drops and X, and then keep on the feature engineering part. I'm not going to take the city, province, and model here. So we will just say x.drop, and we will say columns, and they are going to be model, city, and province. And then we are going to say in place equals to true. Also, there is a problem. Let me just quickly fix that. And now I think it's fine. And if we check X again, we are going to see we are going to have 5 columns. So for our models to learn, we need numeric values in our X columns. But here we have categorical columns. So we need to do encoding for changing them into numeric ones. Also, after that, we are going to do scaling because we have numeric values in different scales. These are going to be 1 and 0, and these are like 100,000. So feature scaling in this kind of scenario is necessary. So for the encoding, we will import preprocessing from sklearn, import preprocessing, and we are going to use label encoder. It's going to be preprocessing.label encoder. We initialized it, and we will say X, and the first column is mark. We will say label encoder.fit and transform, and we will say X mark again. And you are going to see our mark column is going to be numeric right now. We can just see the unique values, and you are going to see it's encoded. Like we will just say unique in here, and we will get the unique values inside of it. So what we are going to do is we are going to do the same operation for the fill. So let's just copy this, add this into here, and we will just give fill in this. And let's just remove this since we already did that. And you are going to see fill is encoded right now. Now we are going to split our data into training and testing sets before scaling it, because if we scale before splitting, it can create data leakage, and it's not generally used way of scaling. So for that, we will say from sklearn.model selection import train test split, and we will say xtrain, xtest, ytrain, ytest. It's a really common step in any machine learning task. I'm just going to tell you why it is. Test size 0.2. So by the test size 0.2, we are putting 20% of our data into testing set and 80% into training set. We are doing train test split because we want to evaluate our model's performance. Like we are going to train our models with this training data, xtrain and ytrain, and we are going to evaluate its performances on a test set. Like in this way, we can just see how our models are performing. We are going to do predictions using our model, which we trained with training data using xtest, and we are going to compare the predictions with the ytest, which are the true values. So the next step is the scaling. So we will say from sklearn.preprocessing import, let's standardize, use standard scaler. Also we have a scaler like min-max scaler. I have a full video about them, you can just check it out for learning when we use them. We will say scaler and initialize this standard scaler object. We will then say scaled xtrain scaler.fit transform xtrain, and we will say scaled xtest. We will say scalar fit transform xtest. Great, we are ready to go. Before starting into the modeling part, let's just define a function for evaluating our model's performance. So let's just say from sklearn.metrics import mean absolute error and mean squared error. Also we will import numpy in here because we are going to say root mean squared error, so we need numpy. Also I need to import mean squared error, I guess, and now we are good to go. By the way, I'm not going to use mean absolute percentage error, so we can just delete it or we can just keep it, there's no difference. Let's define our function for evaluating the models. We'll say define model results and we will say predictions. We're going to give the predictions inside of our function and we will say print mean absolute error on model is, and we are going to use format. We are going to do string formatting and then we will say mean absolute error. We will give the y-test, which are the true values, and predictions from our model, which we will give in the function at the start. So for the next step, we will say print root mean squared error on model is, and we are going to use string formatting again. We'll use numpy.square root. Then we will say mean squared error, and we will use y-test and predictions. Now our function is ready and we can start to the machine learning part in here. Let's start with the linear regression. So we will say from sklearn.linear model import linear regression, and we are going to initialize it like linear regression, and let's just fit this using our training data. We are going to train our model scaled X-train and Y-train. And now we can get our predictions like predictions linear regression, and we use linear regression.predict, and we will get scaled X-test in here, and we can just call our function for evaluating our model's performance. Our mean absolute error on the model is 32,000 and root mean squared error on model is 56,000. In the classification matrix, generally the higher is better, like higher accuracy is always better instead of the overfitting scenario, but in the regression evaluation matrix, we are going to look for the lower values. Great, let's keep with the support vector regression. And I'm not just going to use the base models, and I will do hyperparameter tuning for all of the models that we are going to use in this video. So for doing hyperparameter tuning, we are going to need grid search. We will use import grid search cross validation, and let's also import support vector machines, import support vector regression. And let's start by initializing our model. Like, actually I'm not going to use capital letters, I will say support vector regression. And now what we are going to do is we are going to create a dictionary for the parameters. All of that parameters is going to be tried out from grid search, and we are going to get the best performing ones in terms of estimating. So let's just define the parameters, grid support vector regression, and we can say C is going to take values like 0.001 and 0.01, 0.1, 0.5, and I think it's enough. And then we are going to say kernel, and it's going to take values like, not like that. We are going to give a list in here for the kernel. We will say linear, RBF, and poly. And we can give, actually not in list, we can give gamma parameter, and we can say scale and auto. And we can also create degree, and we can say 2, 3, 4, and 5. Also I need comma in there. And here's our parameters. The next step is we are going to say grid SVR, and we will use grid search cross validation SVR model. And what we are going to do next is we are going to give the parameters we created. The next step is fitting this into our training data. So we will say grid svr.fit, and we are going to train our data using our training set, and we will say y train. Okay, it's taking forever to my computer to train this model, so I just decided a thing that I'm going to show you the parameters for the models and how you can do parameter tuning. You are going to use grid search in all of them, but I'm going to use the base models because I need to record this video and I can't wait for every model to train in like 30 minutes. So I'm just going to stop this and I'm going to use this SVR model. So with using this SVR model, it's going to be trained much faster. And if you want to do hyperparameter tuning for the model, I'm going to be showing you these parameters for all of the models and how we can use grid search, but I'm just not going to do that on the video. So let's go like SVR model.fit and we'll use scaled X train and Y train for training our model. And then we are going to do, actually let me wait for this base model to fit real quick. I feel like even this is going to take a lot of time because let me check, we have more than 100,000 rows and it's hard for computers to train these large models actually. Okay, we will get the results of this when it's finished. So now I'm going to show you the parameters of the decision tree regression. I'm not going to do hyperparameter tuning, I'm saying it once again. Also in tree-based models like decision tree and random forest, you don't need to scale your data, you can use the X values directly, but I'm going to use the scaled versions on the model training. So the parameters for the tree model is, you can just say parameters grid tree, and you can say like maximum depth. Also there's different parameters too, you can just check scikit documentation for that. You can just say 5, 10, 20, 30 for this. And for the minimum sample split, you can say 5, 10, 15. And for the minimum samples leave, you can say, also you need codes. You can say like 2 and 4, 6, etc. And how you do hyperparameter tuning on decision tree is you are going to import decision tree regression from sklearn.tree. And the next step is going to be initializing the tree model like decision tree regression, and then the next step is you will define grid tree like grid search cross validation, and you will say estimator is going to be equal to the tree model, and parameters grid is going to be, actually you need lower letters for that, actually be parameters grid tree in here. And the last step is going to be using grid tree that fit, and you will use scaled X train and Y train. Also you can use the normal X train, and in this way you can train a hyperparameter tuned decision tree regression. Also you can expand these lists if you want to get better results, but for just showing, I want to show you how we can tune a decision tree model, and our model is trained and we can get the performance of that now. So let's just get predictions with this. Let's say predictions support vector regression, and we will say SVR model.fit. Actually we need to use predict, and we will use scaled X test. And let's get our model results function, and we will say predictions support vector regression after the prediction process. So we got our predictions, and I'm just going to run this, and we can see that our mean absolute error on model is 40,000 and root mean squared error on the model is 81,000. Okay, now I'm going to show you a final algorithm. I'm not going to train any more algorithms in this video. I'm going to show the random forest regression, and I'm going to train a base model, and when I'm training the base model, I'm going to show you which parameters you can give into the hyperparameter tuning of the random forest regression, and how we can train a hyperparameter tuned random forest model. So let's say from sklearn.ensemble import, again it's a tree-based model and you don't need to scale your data, but I'm just going to give the scaled version, and I will say random forest classifier, and I'm just going to do RFR model.fit, and I will give scaled version of our data, scaled X train and Y train. When it's training, I'm going to show you how we can do hyperparameter tuning. So you can just open a dictionary like parameters, grid, random forest regression, and you can say bootstrap and use true like this. And let me just delete this. And then you can just do maximum depth, and you can just use 2, 5, 10, 15, 20, and then you can say maximum features, and you can do also, let me press enter on here so we can see better. You can say auto or log 2, and you can say number of estimators and 3 and 4 in here. And after this you can do grid random forest regression, grid search cross validation, RFR model, and then you can do parameters grid RFR. And at the last step you can use grid RFR dot fit scaled X train and Y train. And after the fitting your data, training your model, you can just use grid RFR the predict, and you can just use scaled X test. Also we have a error on the model, let's check it out. Okay, I just restarted the kernel, and you can just use that predict after grid RFR, and you can use hyperparameter tuned random forest regression like this. I'm going to wait for our model to be trained, and then I'm going to start recording again. I just recognized that I'm trying to use classifier, not the regressor, so it's the reason why it's throwing that error. And if I just change it to regressor, it's going to work smoothly. And here we have our model. I think I'm too tired, I didn't even recognize that before a minute, and now we can just do predictions with it. We can say RFR model dot predict, and actually we won't use dot in there, RFR model dot predict, and we use scaled X test, and let's store this like RFR predicts. And then what we are going to do is we are going to say model results, and we will give the RFR predicts in here. And we can see that our mean absolute error on the model is 14,000 and root mean squared error on the model is 30,000. That was all for this project. Thanks for watching. I'm creating content about data science and programming. You can subscribe to my channel for more. Have a great day.